Hello everyone and welcome to our channel. Today I am presenting our amazing project called Weather Station. However, it's not a simple weather station. It also can be used as a universal condition monitoring system everywhere. In this video, firstly, I will talk about the problem which our system solves. Secondly, I will briefly overview the design of the proposed solution. Then, I will talk about main stages of the project, following by explanation of the written code in C++, user interface, and key installation steps. Finally, the lifetime demonstration will be provided. Let me start with the problem. Once upon a time, my boss said me, "Damir, you are an IT engineer. Could you please find me some cheap and convenient monitoring system for my house in the countryside?" He wanted to know the statistic information about temperature in his house during cold winter times when he lives in the city. Later, another friend of mine told me that he is looking for monitoring system for his personal Bitcoin mining farm. He aimed to control humidity and temperature in his so-called data center. We tried to find something on the internet and faced a problem that existing out-of-box solutions on the market are quite expensive and are not very flexible. Together with my friend from Glasgow University, we decided to develop a solution based on Raspberry Pi, which addresses this issue. Okay. Let's move to the proposed solution. Concerning the brief overview of the design and technology used in our project, I can say that it's not very complicated as you see on this picture. Thus, it is easily reproducible and quite effective and convenient. As you can see on the slide, the solution consists of three main components: the PCB with sensor installed on it, the Raspberry Pi with Nginx server and MySQL database server installed on it, and the user interface written on PHP. The development of the project can be divided in four main stages, which you can see on this slide. Also, all members of the group have been actively involved in the process. Different processes have allocated some specific different person allocated some specific tasks. Aurelia was responsible for PCB design and soldering, which is related to hardware design and production. Craig and Damir worked on software development, writing code in C++. Graphic user interface was designed and developed by Damir. Finally, all team contributed in installation and testing of the project. Let me describe the designed board in more details. As you can see on the figure, there are two boards. The first one on the left side is connected directly to Raspberry Pi's GPIO ports. The level shifters, number 1 on the picture, are used in order to increase the length of the cable which connects the second board with the main board. This provides enough flexibility, and the board with the sensor can be installed remotely in any place of the room or even outside. On the second board on the right side, two digital sensors are installed, which operates through I2C protocol. The sensors are quite tiny and very cheap. Two boards can be connected by means of the standard UTP cables. The length of the cable can be even 10 meters if you wish. Regarding the development software, it can be mentioned that program written in C++. The data flow diagram is presented in the figure which you can see now. The program consists of two main threads. The first one reads the data from the sensor and sends it to the MySQL database every 10 seconds. It is on the right side. The second thread, which is on the left side of the picture, pulls database and checks the condition every 5 minutes. The timer is used to realize these functions. In addition, it is possible to configure email notification for specific stream condition. For example, when the temperature is below 0 or above 35 degrees for last 5 minutes, the system can automatically send email alerts to the user. The web interface has two main pages. On the main page, user can see the current data from the sensor and two graphs displaying the data for the last 6 minutes. On the second page, some statistical data is available, for instance, the changes of the temperature and humidity for the last week or day. The web page is developed in PHP. Google Chart Tools, JavaScript, JSON have been applied to display statistical and real-time graphs. Now let me give some information regarding installation of the system. First of all, you need Raspberry Pi with Linux installed on it. Then you need to install MySQL database server, web server, it might be Nginx or Apache, PHP and SSMTP for email notification. After the database installation, you can create a database. The SQL dump is provided in the GitHub page of the project. The source code of the program can also be downloaded from the GitHub page of the project and compiled on your Raspberry Pi. Finally, in order to make the program start automatically with the system, one command line should be added in the rclocal file. This is all about the general overview of the system. Now let me demonstrate how the system works in the real time. We have already connected the PCB to Raspberry Pi GPIO I/O ports. Then we connected the second PCB with the sensor to the main PCB, and I plugged in the power. I just plug in the power, and it will take approximately 60 seconds to start all necessary services. And we go to the web page, and here we go, the program is working. On the main page there are two widgets which show the current data from the humidity and temperature sensors. As you can see, they change dynamically every 10 seconds. 10 seconds is permitted refresh rate for the user interface, which is fine for this system. On the second page, there are some statistical information for the past period. Now I will show you how the system reacts on the change of environmental conditions. For the testing purposes, let me artificially increase the temperature by putting the sensor's module on the hot radiator. As you can see on the interface, the temperature is going up and the humidity is falling down. Another useful feature of the project is an email notification. As soon as the sensor data reaches some extreme condition set by user, the system notifies the user by sending an email. Since we have increased the temperature artificially, now if you check your email, you will find that there should be alert notification email from the weather station. Let's go here. Now if you open your email, you can see there is an alert notification from the weather station. The temperature was 28 degrees and humidity was 40 degrees at this time. It shows that something happened and we need to make some action about this. This is a basic functionality of the system. Nevertheless, it solves the main problem which is designed for, by providing statistic information about the temperature and humidity in the room and sending notification in case of some extreme condition happened. However, new sensors and modules can be added in order to increase functionality of the system. For example, it might be admin page for the email and pooling interval configuration. This is all about our project so far. You can find more information on our GitHub page. The link is below this video, and thank you for your time.